empty out there. So negative, and negative implies it's opening down. Now what that also gives us then is it's either max or min. With that being a negative opening down, we got ourselves a maximum. And what that also does for us, as we introduced to you guys yesterday, that gives us the end behavior. So we got ourselves some type of graph opening down. Now, as I talked to you guys yesterday on, and I'll do it again for you today. Okay, when you guys go to next week and answer these first questions out here on end behavior, that's how it's going to be written out. Where you just need to complete the two blanks, right? But now you got to know again how that is being asked. The way that this is asked here is this is saying as x goes to negative 50. As you plug in the x values, you plug in that domain, going to the negatives, what's happening to the range, what's happening to the y values. The y values are either going positive or going negative. Now next year that's going to change up, but we're not to next year yet, are we? So the y values, as x's go to the right, what are your y values doing? Are your y values going up or your y values going down? It's going down. What's your graph doing? Your y values are going down. So when we say they're going down forever and ever and ever, right? So we're going to say the answer is negative infinity. As you start plugging in these x values, going to positive infinity, as the x's are plugging in, when x is 1, 2, 3, 4, 5, 10, 100, 100 million, what type of outputs are you getting? What type of y values are you getting there? Positives or negatives? So the y values are also going down to negative infinity. Sorry. Yeah, it is negative infinity. I wrote it. Down to negative infinity. And if you haven't noticed from yesterday, and then still things be today, the end behavior for the quadratics, they're going to be the same. That's not always true. We'll look at cases next year where that's not going to be the same. And we're going to look at cases where they don't always go to infinities. That's not this year. We're just laying the groundwork. Okay, that's all from just knowing what the lead coefficient is. That's just by knowing a simple sign. Now after that, we got to start finding some numbers here and building the graph. All right, we can go about this as negative x squared minus 4x. We talked about finding the x-intercepts by remembering that along here is where those x-intercepts are, and every point that's on the x-axis, all these coordinates for the y value, they're all something comma 0. That is something comma 0. So what we talked about doing here is setting this thing equal to 0 and solving for x. Okay, we use our GCF. Okay, we use our GCF here. C is 0, and our GCF here is, as we've done throughout, we bring out a negative x. When we said before, we ran some instances where the lead coefficient is negative, we bring out a negative x. And all that does for us is flip our signs. Now, here, what are our two solutions? One solution is always going to be 0, and the other solution just depends on the problem. In this case, the one solution turns out to be negative 4, and the other solution turns out to be always 0. That will always be the case when there is no constant term. So when I look at that answer there, and I'll put this in my calculator here in just a second to confirm what I did by solving by hand, your calculator is your buddy. You guys will be able to use your calculators on the SAT, PSAT, whatever you're taking in April. So get to know how to use those. All right. So I'm going to check this now, knowing that the x-intercept should be at negative 4, 0, and at 0, 0. Now I get my answer key there, and the next thing is, before I plug that into my calculator, I'm going to go find those other two key points, the y-intercept and the vertex, and then I'll plug it into my calculator to make sure I'm correctly doing it by hand. We said the y-intercept is, again, on the y-axis, and that y-axis happens at 0 comma something. So we go back there, plug in that 0, and we want to make sure that you're plugging in 0 correctly. This is an input with the output. Input is x, output is what? Sorry, input of x is 0, output is what? that just zeroes out. Negative 0 squared minus 4 times 0 is just, it's just 0. Which makes sense because why? It's going at the origin. This x-intercept was at the origin. That is the one time where the x-intercept and y-intercept is one and the same, when it is passing through the origin. And that's actually, you do enough of these, that's always going to happen when the constant is 0. That's always going to happen when this is constant 0. You're going to run into that situation. Okay, axis of symmetry is needed. As soon as you found those two, whatchamacallits, the x-intercepts, you've got yourself the axis of symmetry. The axis of symmetry is, we talked about that midpoint yesterday. It's right there in that middle between -4 and 0. What's in between -4 and 0? -2, right? There's my axis of symmetry. I always like to draw that in because that helps me go down here in just a second. So as Caden just said, -2. And please say x equals. If you just tell me -2 next week, I'm going to mark it wrong. Axis of symmetry is an equation. X equals -2. -2 comma something is my vertex. Now what is that comma something? You got to plug it back in. That brings me back to that functions work we did, evaluating a function. The input's -2. This is the work that you did back in Algebra 1, my sophomores, with evaluating functions. Now, here's where the mistakes happen, though. The equation reads -x squared minus 4. X is -2. There's a bunch of negatives going up there. You sure as heck better use those parentheses correctly. So I'm going to my calculator. I hope I'm going to go correctly. Punch into my calculator with the negatives and parentheses. Does that match what my equation says? Was that plus or minus though? It was a -4. Okay, so all looks good. The output is 4. Now, if you got a -4 there, because I can see a negative screwing up with somebody, think about what type of graph we're expecting. It's supposed to open down. If you tell me my vertex is supposed to be here, that graph's opening up. That doesn't make sense. You are expecting to get a maximum. That's a minimum. And I would totally buy that. A -2 comma 4, that makes sense. So that looks like the graph I should be getting. Now I'm going to go check with my calculator. So perfect practice here. If you don't have your calculators out, you should have decimals pulled up. Okay? So let's get going on that. We only did a handful yesterday. You did a couple last night. We're going to do some more today. Get good at that, because next year in Algebra 2 honors, I don't care where you're going, next year these graphing calculators, you're going to use them every day. So of course this summer, I would encourage you strongly to get yourself a graphing calculator, a TI graphing calculator. Okay? Casio's, nobody really knows how to work a Casio operating system. I would use the TI. All right, let's rock and roll. We hit y equals. And again, if you need to use your Desmos for that, we'll do that. Negative. Here's our variable button. That's our variable x squared. I think it was minus 4x. It's stored in there. We go hit graph. Fingers crossed, it's the same thing we just calculated by hand. Okay. I always do that to confirm that I do something right or wrong. It does appear I get the same graph. Okay, 0, 1, 2, 3, -4, -2. Caden said for axis symmetry, and then 1, 2, 3, 4. There's my vertex. It does turn out to be a maximum like we predicted. Everything seems to be jiving there. But your calculator is your buddy. So you can definitely always check it with that. You should be able to do both ways, by hand and with the calculator. If you can't do it by hand, by hand, the calculator you can at least rely on. Okay. All right. Finish it off. Once you found that vertex value, that maximum value, you've got that now. 4. We don't have any walls, do we? Make sure we U that out. Finish the graph. Finish the graph, U it out. Okay. The domain. We don't have any walls, so we keep saying, I don't think that's ever changed up for us lately. Negative infinity to positive infinity. And as soon as we realize it's opening down, you should also have in your head that you have a ceiling here. Not a floor, but a ceiling at this point. So the range is going to go negative infinity all the way up to, I just didn't know where a maximum was. So I could have done this, but I just didn't know where a maximum was going to be, and now I found it at 4. And then the other thing I knew was going to happen at the very beginning here is, because it was opening down, I knew I was going to increase first. So I was going to increase first, starting at negative infinity. I just didn't know where the split was going to happen. Caden said the split happened at where? -2, the axis symmetry. And then it proceeds to then decrease on there to infinity. That always comes from the domain. Okay. So if you look at your answers and you've got those, then you're pretty solid. That right now is as worse as it's going to get. We'll get worse, but not right now. Okay? It'll get much worse, but not right now. Okay? All right. We're going to do more work with that today. So we'll get a lot more practice going on. Anybody on the back side of the factoring? This is your chance to ask about the factoring. He was ready to jump out of the chair and run up there and put it in. Okay. Eva, on your mark, get set. That's a great start off the line. Max or min, right?
Yeah.
It's a min. Once I realize it's a positive, I'm gonna go ahead and just draw maybe an itty bitty graph of what I may expect. Just that's what I'm expecting. What else does that do for me? It gets me my in behavior already. So on my in behavior, again, I'll say it. This is what I'm gonna have for you. You gotta fill out the 2 blanks. Okay. And on that in behavior, all right, as x's go to negative infinity, what are your y values doing? I'm sorry? Going up to infinity forever and ever and ever. As the x's go to positive infinity, what are your y values doing? Y, MCA. Yeah, so we're going up to infinity, aren't we? I am not going to dance for you. Nobody wants to see that. This is Dresh. She makes fun.
Nobody wants to
No,
see
nobody.
that.
Anybody watch Seinfeld?
No.
Okay.
Oh, I've seen clips of it.
Okay. Yeah, it's just, one of the characters on there is a bad dancer. It's like that. It's terrible. Okay, what else do I have? I've also got, I got the idea of knowing what comes first, the increasing or decreasing. Knowing it opens up what's going to come first, increasing or decreasing. It's doing what now? It's decreasing. So I know this already. The only thing is I don't know where the split happens. And I know once I know where the split happens, it's going to proceed to increase. What else do I know? I know what the range is already. The only difference on the range is I don't know where the floor is at. What's the, I have a floor, but I don't have a ceiling, do I? I got that already. Just by knowing what the sign of the lead coefficient is. And the other thing I keep throwing out there, this domain's not changing up, is it? It's still negative infinity to positive infinity. I filled out a ton of that just by knowing it's positive. Okay? All right, now we're finally stuck. Let's go plug into our calculator. All right, what do we got? Y equals, clear out the old one, x squared plus 2x minus 3. Graph it. Decimals, people, you know how to graph yours. All right, let's continue with the analyzing there. What do we have for our x-intercepts there? X-intercepts are located where? Appears to be at 1, 0 and -3, 0. So we can do it by hand. We can see up there that I could see where 1, 0 is happening and -3, 0 is happening. Can I see my y-intercept up there? Where's my y-intercept located at? 0, comma what? -3. I've got my axis symmetry. I've got my vertex then as well, don't I? Where's my axis symmetry at? -1. I can see it coming from the x-intercepts. I can see it on my graph. 1 plus -3 is the midpoint. 1 plus -3 is -2 divided by 2. There is that x equals what? -1. Again, I can see it right there. And if you look closely at that vertex, -1 comma dips down to where? -4. As soon as you found that vertex, I can finally finish off most of everything else. That minimum value is where? Yep, -4. And as soon as I found that minimum value, that finished off my floor, finished off my range, didn't it? I was just waiting on that, but I had already that waiting for me. And then I had that split waiting for us as well, because I just didn't know where the axis symmetry was going to be at. Where did the axis symmetry turn out to be at? So it's decreasing, and boom, it happened at the axis symmetry at -1, and then it proceeded to increase. So I cannot, again, stress the importance about knowing what the sign is. The sign tells you a lot. Okay, the lead coefficient. Graphing calculators are your buddy. Now, the one question I didn't do yet is the vertical stretch or shrink, or neither. I'm going to talk about that here after I do the next two. Okay, let's go with the next one. All right. Now, this next one I did change up just a little bit. But who cares? Let's go ahead and do the sign. Don't do anything else. Let's just talk about the sign real quick. Sign is what? Negative. So what type of graph am I expecting? Opening down, right? What's that give you? Gives us a maximum. Gives me my M behavior. I'm going to show you a small trick on this one. A graphing calculator trick. Okay, give you a sec there. We know it's that. Alrighty. X's are going to the right. What are your y values doing? Going up or going down? I'm sorry? Down. So we're going to -infinity. Your x's are going to +infinity. What are your y values doing? Same thing. Correct. So I'm going to give you those blanks. You fill out those blanks. And they will always be the same until they're not next year. Okay? I got the domain. Domain's not changing. We could just go right now and I think fill out the domain for all these as the same. Eventually your domain changes up. But for quadratics right now, we ain't. I've got the range. What do we have on this range? A floor or a ceiling? We got a ceiling. So we're starting way down here at -infinity. The only thing is I don't know where I stop at. At that ceiling, I don't know where. And what happens first? Does this graph increase or decrease? It increases. At -infinity, I just don't know where the split happens, and then I start to decrease. Again, all of that's because of a negative. Okay, I need to complete that table. It's just good practice with inputs, outputs. It's good evaluation skills. Now, before I do all that, though, don't do all that. I'm going to show you a small trick. Let's go put that into our calculator. Okay, let's clear that thing out. Let's go punch in -2 x squared plus 12x minus 16. I'll give you all a second. Desmos people, again, you're doing the same thing there. Go ahead and hit graph. We'll come back to this table in a few minutes. Go ahead, hit graph. And what type of graph do we get? We get that, don't we? It is going down like we expected, and you can continue to analyze it, right? All right, let's analyze that thing. Where's my x-intercepts at? X-intercepts are where, guys? 2 and 4, yeah. 2, 0, and 4, 0. Oof, crap. Y-intercept, I can't see it, can I? That's no big deal. It's easier to actually just look at the equation and tell me what the y-intercept is. Because, one more time, the y-intercept always occurs when x is 0. that becomes 0. That becomes 0. 0 plus 0 minus 16 is negative 16. Does that kind of would seem to jive where 0, negative 16 maybe would happen right there? I'm hoping it does. We're going to see that here in just a second when I give you a different viewpoint. All right. Axis of symmetry. We got that. Axis of symmetry between 2 and 4 is, yep, 3. We got the vertex now. 3 comma what? 2. You said it was a max a few minutes ago. We now get the maximum value at 2. Now I got the ceiling. I got the range. And because the axis of symmetry, I got the split. You said it was increasing first. You just didn't know where. Now it's split to what? Not 2. 3, right? Remember, it's the axis of symmetry. I know it's accidentally easy to say that the maximum value at 2 because your eyes draw up there, but it's on the domain. Okay? All right, so now I'm going to show you a small, nothing major, but it does help with some things here. Okay, what I want you to do is on your graphing calculator, and I'll do this one decimals here in a sec. Hit second graph. What's it going to do? Change my graph to a table of values. So I'm not going to keep doing what I had you do in the very first one. What you just did here is you told your calculator to evaluate all the integers. So when I want you to go through and evaluate all these integers, your calculator does it for you. All you got to do is just, what's negative 3? Okay. What's negative 2? Okay, your calculator is evaluating all the integers for you. Negative 1 is what? Negative 30. 0 is what? Hey, 0, negative 16. What does 0, negative 16 represent? That is code for I am the y-intercept. Look at me, I am special. I know your parents say, oh, you're always special. Okay, I don't tell my kids that. But 0, comma, negative 16. Neither does Mrs. Dresch. 0, negative 16, that is my y-intercept. That makes sense. 5, comma, what? So I don't need to evaluate because my calculator will do it for me. All right. If I go find 2, 0 and 4, 0, right there, again, those are 2 special points as well. On this whole table, I'm going to see 3 special points. It's not going to say special points, but when I see 2, 0, 4, 0, those are 2 special points. Those are representing your x-intercepts. That's the only time those occur. And again, that third special point, 0, negative 16, it's the y-intercept. It's not going to say I'm the y-intercept or I'm the x-intercepts, but you have to realize those are your special points. Okay, now to my decimals people, and then I'm going to do something here in just a minute. Y equals, what was it, negative 2, x squared, what's the next piece? What was it? Plus 12x, and then what? Minus 16, duh. Okay, if on yours, shoot. How the hell did I change it to table values? I just do the table. What reference up top? Try to think if it will toggle between a table easy enough, or if I got a reference up top somehow. Okay, my decimals people, you might have to give me a minute off of that one. I don't know if it's going to allow me to pull, or I have to define that. I think I have to define that. So my decimals people, you might have to right there, I had to define the variable, so you're not, I can't promise you quick things on that one. Sorry. Okay, now the next thing I want to do, I'm going to use my decimals here because I can get 2 different colors. What was the first one we did? Y equals, what was it? X squared plus 2x minus 3. Okay. Now on these 2, that's not stellar. Let me try this again with something else because with the different sizes there. Let's try this. Hold on there because it's not with that. X squared minus 4. Just keep it as x squared. All right, let's try this. Because now I want to talk about that question I have not talked about yet. 2x squared. Okay, I got my black graph, I got my red graph. Okay, the black graph is similar to what we did on question 1. It's x squared, x squared. The red graph is similar to what we just did now, 2x squared. Okay, what that 2 just did is what to my graph? How would you describe what that 2 just did to my graph? I'm sorry? Okay, so what we call that here is actually that 2, what that did is, it took my graph and actually it stretched it out, okay? So what that 2 just did to my graph is what we call as a vertical stretch. So where are we at? This is what we have is called a stretch because of the A is 2. Has nothing to do with the negative. It has everything to do with being a 2. Now, on the next one that I have, I'm going to jump ahead to that one real quick. I'm going to throw a third one out here. And on that third one, I'm going to throw y equals 1/2 x squared plus it. And I'm going to take out that negative because I don't care about the negative. I don't know why I did that. Now, what did that do? That made it wider, didn't it? So what we call that one is we call it a shrink. We call it a shrink, or what we also call it is what we call as a compression. Either one's fine. A shrink or a compression. We tend to go now more with the word compression. When I think of compression, I think of like CPR. Okay, we do chest compressions. So what the 1/2 did was made it what we call a shrink or a compression. We're going to use those words interchangeably because A was 1/2. Okay. So your baseline is 1. And that's where we're going to say that is considered to be neither because A is 1. Everything that we did yesterday, A was 1, A was 1, A was 1, A was 1, A was 1. That's your baseline. Once it's not 1, it's either a stretch or a compression. Those are your 2 options there. Okay? If it's greater than 1, we get what we say is a stretch. You get those values start to be stretched out. And if it's between, we say 0 and 1, you start to take them in halves or thirds or whatever, we start to compress it. We get it as what we say is also a shrink. So it gets a little bit wider type of graph. Okay. So with that, we finish it off here. Okay. Let's go and finish this off by running this last one. 1/2 x squared minus 2x plus 1. What do we have? We got a positive. It's going to open up. What else do we got? It's going to be a what? Min. And we got the end behavior. What's the end behavior going to do? Go to positive infinity or negative infinities? It's going to go to positive infinities. Okay. I know my domain's not flipping changed. I know my range has either what? Floor or ceiling now. Range has a floor. Whoops. There's some room there. Yep, it's got a floor. And I know I either increase or decrease first then. What am I doing first? Increasing or decreasing? I'm decreasing. I just don't know where that split happens. And then I increase. That's a lot because of a positive lead coefficient. Now, this last one here, well, crap. It says something about rounding. That's gonna suck. Okay, that's fine. Let's do this. What's that? You don't like this one, Yante? Alright, you'll live. Maybe, I don't know. 1/2 x squared, what is it? Minus 2x, and what? Plus 1. Alright, make sure it's all typed in correctly, and let's hit graph. Yante said he doesn't really like this one. Do you know exactly where that's at?
Nope.
Nope. What's it look like it's at? I don't know. They do look different. Okay. All right. Well, I'm going to show you one last thing here today on your calculators. All right. No, I'm not. I'm not going to mess with you anymore. We're going to pause it there. You're welcome. Yeah, they do hit different. We're not going to worry about it. Okay. So today's stuff. Okay. It's